At 0623 local time, an RQ-4 Global Hawk is holding a racetrack orbit at 60,000 feet above the Strait of Hormuz, its synthetic aperture radar painting the Iranian coastline 80 miles north. The feed reaches CENTCOM in Qatar in under 400 milliseconds. 3 Iranian fast attack boats have been loitering near Keshem Island since midnight. They haven't moved. But an IRGC Aerospace Force radar just lit up 12 miles northeast of Bandar Abbas, and that is a different conversation entirely. The Global Hawk isn't a fighter jet. It doesn't maneuver, doesn't shoot back, and doesn't particularly care who's watching it from the ground. At 60,000 feet, it sits above the operational ceiling of most of what Iran can realistically throw at it. The airframe costs $220 million and carries a sensor suite sophisticated enough to read container markings on a ship from cruise altitude. It's been flying this same orbit since the ceasefire took effect on April 8th. 43 consecutive days, same stretch of water, same altitude band, same 12-hour rotation. Iran has watched it complete this loop hundreds of times. What changed at 0619 is that a new targeting order came down from an IRGC brigade commander, and a Tor M1 battery 800 meters west of that radar console just completed its initialization checklist. The Tor M1, NATO designation SA-15 Gauntlet, is a short-range air defense system built around a single transporter erector launcher carrying 8 ready missiles. Engagement range, 12 kilometers. Maximum rated engagement altitude, 6,000 meters. The Global Hawk orbits at 18,000 meters. Those numbers don't reconcile. The IRGC operators know it. The order comes through anyway, which tells you something about the decision-making climate inside that brigade on the morning of May 19th. The Tor M1 system entered Iranian service in 2007, delivered through Russian military channels as part of a broader air defense modernization program. It replaced aging Rapier and Hawk batteries across 4 Revolutionary Guard Air Force brigades. The system was designed for NATO aircraft operating between 500 and 6,000 meters, Cold War tactical doctrine built for subsonic bombers and transports flying predictable corridors over European territory. Nothing in the Tor M1's design parameters anticipated a platform like the Global Hawk, which combines low thermal signature, acoustic stealth, and operational altitude that sits 200% above the system's certified ceiling. The IRGC had conducted exactly 1 live-fire exercise against a high-altitude target in the previous 18 months, and that exercise used a modified engagement envelope that the battery commanders knew violated the manufacturer's specifications. But orders from headquarters override engineering reality when political pressure overrides prudence. At 0631, the Tor M1 acquisition radar goes active. The Global Hawk's onboard threat warning system logs the emission instantly and timestamps the frequency, pulse width, and bearing. That data auto-transmits to an RC-135 rivet joint orbiting over international airspace 140 miles west. Think of the rivet joint as a flying signals intelligence vacuum cleaner. 30,000 pounds of antenna arrays and processing hardware packed into an airframe the size of a regional passenger jet, pulling in every electromagnetic pulse within a 500-mile radius and feeding it to analysts in real time. The Tor radar ping reaches the rivet joint's receiver 0.3 seconds after it reaches the Global Hawk. 2 nodes, 1 network, both watching the same threat from different positions simultaneously. The RC-135 rivet joint represents 45 years of iterative development, the airborne signals intelligence platform that has supported every regional conflict since the Cold War's final decade. This particular aircraft, tail number 62-4133, has logged over 28,000 flight hours and has been deployed continuously to the Central Command Theater for the past 11 months. Its antenna suite includes the Magnum E-Lint collection system, the comfy Levi's Signals Intelligence Processor, and the Senior Ruby Passive Direction Finding Receiver, each tuned to capture specific bands of electromagnetic activity. The crew of 34, pilots, navigators, signals officers, and intelligence analysts work in compartmented watch rotations with 4 dedicated E-Lint operators focused entirely on air defense emissions. They've been tracking this particular Tor battery since April 17th, when it transited north from its garrison position near Qazvin. Its engagement history, maintenance cycles, and operator proficiency profiles are already cross-referenced in the CENTCOM intelligence database, with confidence ratings derived from 6 months of continuous observation. The first launch happens at 0634. One Tor missile off the rail at Mach 2.8, climbing hard on an intercept solution toward a target flying 12,000 meters above its maximum rated engagement altitude. That's not a tactical miscalculation. That's firing a pistol at a commercial aircraft and expecting it to work. The missile burns through its propellant in 15 seconds, the seeker loses acquisition lock at 5,800 meters, and the warhead coasts unpowered for another 11 seconds before falling back into Iranian territory. The Global Hawk doesn't adjust its orbit by a single degree. It's still painting Keshem Island when the spent interceptor hits the ground 3 miles south of the launch vehicle. By the time that missile impacts the desert floor, the RC-135 already has the complete engagement record, radar activation timestamp, missile launch signature, intercept geometry, failure mode, and critically the Tor battery's exact grid coordinates, derived from passive triangulation the instant its radar went active. That battery just broadcast its own position to every Allied signals intelligence platform within 400 miles, spent one of 8 ready missiles on a target it physically couldn't reach, and generated a targeting package that will be sitting in a CENTCOM strike cell queue within the hour, like leaving your car running in front of the building you're robbing. The second launch happens at 0641. Same battery, different fire control solution. The IRGC commander has pushed the Tor M1's elevation parameters past their certified limits, which is the kind of thing that happens when a headquarters order overrides engineering reality. The missile climbs roughly 400 meters higher than the first attempt. It still falls 11,200 meters short of the Global Hawk. 2 missiles expended, 6 remaining in the magazine. The RC-135 logs the second emission signature, tightens its coordinate solution by another 6 meters of accuracy, and broadcasts the updated fix on Link 16 to every Allied asset currently in theater. The targeting cycle accelerates now. The strike cell in Qatar receives the updated coordinates with a confidence assessment of 95%, built from passive triangulation data that has built iteratively across 22 minutes of continuous observation. The strike cell validates the information against satellite imagery from the previous 72 hours, confirming vehicle positions and corroborating the electromagnetic emissions with known Tor M1 deployment patterns. A strike coordinator cross-references the updated grid against the rules of engagement for this specific sector of the strait, confirming that direct action against an air defense battery firing into international airspace at a surveillance platform remains within the prescribed authorities. The request package reaches the USS Baton's Umbat Information Center 14 minutes before the third missile launches. 40 miles south, the USS Baton is making 18 knots into a light headwind with 2 FA-18E Super Hornets parked on the flight deck. Full fuel loads, AGM-88 HARM anti-radiation missiles on the inboard pylons. The HARM, high-speed anti-radiation missile, is purpose-built around one idea. It homes on radar emissions. You turn on a radar, the HARM finds it. It doesn't need a preloaded GPS coordinate. It tracks the signal itself. And if the emitter shuts down mid-flight, the baseline HARM remembers where the signal was and keeps flying toward that point. Turning off the radar after a HARM launch is like hanging up the phone after the police have already run your number. The record doesn't disappear with the call. At 0649, the Tor battery fires a third time. The brigade commander is apparently committed to this approach. Third missile, same geometry, same result. The Global Hawk continues its orbit, unaffected, still feeding imagery south to Qatar at 400 millisecond latency. But that third emission provides the last data point the targeting solution needs. The RC-135 refines its triangulation to an 8-meter circular error. The Baton's Combat Information Center receives the updated package. The Super Hornets are already running their pre-launch checklists. At 0653, the lead Hornet rolls to the catapult. The pilot has been sitting in a cockpit running above 100 degrees Fahrenheit for 40 minutes with both GEF 414 engines at idle. One catapult shot, 0 to 165 miles per hour in under 3 seconds, and the aircraft is climbing south before turning north for the coast. The wingman follows 90 seconds behind. Neither pilot will ever see their target with naked eyes. The AGM-88 EAARGM doesn't require that of them. The AARGM, Advanced Anti-Radiation Guided Missile, adds a millimeter wave terminal seeker and a GPS navigation mode to the baseline HARM design. It solves the one scenario where the original HARM becomes unreliable. The radar shuts down before the missile arrives. The AARGM doesn't guess about where the emitter was. It knows, and it goes there regardless of what the target crew does with their power switch after launch. The weapon weighs 800 pounds, covers 150 miles of range, and that upgrade cost the Air Force 13 years and $400 million to develop. On the morning of May 19th, it's earning every dollar of that invoice. At 0701, the lead Hornet reaches launch altitude at 28,000 feet. 90 miles south of the Iranian coast and well outside the engagement envelope of anything functional in that sector. The weapons officer confirms the targeting solution fed down from the RC-135's passive coordinate fix. He pickles the AARGM off the port inboard station. The missile separates cleanly, the rocket motor ignites, and the weapon climbs northeast on a ballistic arc toward Bandar Abbas. The Tor battery's radar is still active at this moment. It's tracking the Global Hawk. It has no indication that anything is inbound, because the AARGM's terminal approach geometry puts it outside the Tor radar's search sector until the final 8 kilometers. The Tor crew has 4 minutes and 20 seconds from missile release. Nothing on their display suggests a threat. At 0705, the AARGM transitions to its millimeter wave terminal seeker, acquires the Tor radar vehicle from 8 kilometers out, and guides to direct impact. The 146-pound WDU-21 warhead detonates on contact. The transporter erector launcher and the radar mast fold into each other. 5 of the 6 remaining missiles in the magazine cook off in the secondary fire. The explosion registers on the Global Hawk's electro-optical sensor at 60,000 feet as a white pulse followed by a rising smoke column, which the aircraft dutifully timestamps and records without interrupting its orbit. The secondary explosion sends a thermal signature visible across the infrared spectrum for 4 kilometers. The Global Hawk captures this with 0.5-meter resolution through its EO/IR turret. The RC-135, still orbiting 140 miles west, receives the confirmation independently through its own passive thermal sensing receivers, which detect the spike of radiant energy from the destruction event against the background signature of the Iranian littoral. The timing of the 2 observations allows for cross-correlation that confirms not just a detonation event, but a specific class of ordnance impact, narrowing the assessment to precision-guided munitions rather than simple unguided explosive devices. Every piece of information is time-stamped, referenced, and fed into an automated assessment algorithm that begins building the post-strike battle damage assessment 15 seconds after warhead impact. The second AARGM impacts the fire control radar station 800 meters east. 38 seconds later, same result. 2 structures, 1 grid square. The entire battery's organic command and control reduced to wreckage in under a minute. The Global Hawk has now been on station for 5 hours and 42 minutes. It has watched the Strait of Hormuz, logged 3 Iranian missile launches against itself, survived all 3 without evasive action, and provided the passive triangulation data that built the targeting solution that just ended the battery responsible. It did this without a crew member on board, without changing altitude, and without deviating from its programmed track by a single waypoint. The RC-135 is already generating the post-strike assessment. Thermal imagery from the Global Hawk's infrared sensor captures the heat signature of the secondary explosions decaying across 12 minutes, confirming the missile magazine cooked off completely. The Tor M1 system costs Iran roughly $25 million per unit. The 3 missiles it fired represent another $3 million in expenditure. The 2 AARGMs that destroyed it cost approximately $1.4 million combined. Iran spent more money degrading its own air defense network than the U.S. spent removing it from the equation. That cost exchange is genuinely impressive, in the worst possible direction for Tehran. The IRGC brigade commander who transmitted the targeting order at 0619 sent it from a communications node 14 kilometers north of the destroyed battery. That node's RF signature was logged by the rivet joint at the same timestamp as the initial radar activation. It's now in CENTCOM's targeting database with a full emission history attached. Whether it moves up the strike queue depends on decisions made in Qatar and Washington over the next 48 hours. The order traveled down the chain of command. The record of who sent it traveled in the opposite direction simultaneously. Itudilam. At 0712, the two Super Hornets are back in the Baton's recovery pattern. Fuel states low, weapons expended. The lead pilot calls the ball at 3 miles on final approach, traps the number 3 wire, and has the aircraft folded and spotted forward within 8 minutes. The AARGM tailfin assemblies are photographed by the ordnance crew as standard post-strike record-keeping. Total elapsed time from the first Tor radar emission to the last secondary explosion on the Iranian coast, 41 minutes. The Global Hawk is still airborne and still on station. At 0744, an IRGC fast attack boat sortied from Bandar Abbas at 40 knots heading south into the shipping lane. The Baton's CIC tracks it immediately on the SPS-73 surface search radar. The boat carries a C-802 anti-ship missile on a deck mount and a crew of 8. It closes to 18 miles before the bridge watch officer receives the rules of engagement confirmation he needs. An MH-60R Seahawk from the ship's air wing is already airborne with 2 AGM-114 Hellfire missiles on the port pylon. The maritime Hellfire variant has an 8-kilometer engagement range, and the Seahawk is inside that window before the fast attack boat reaches 15 miles. 2 shots. The hull goes dead in the water, drifting south on the current while the Seahawk's FLIR turret timestamps the thermal decay of its engines and transmits the footage back to the Baton's Combat Information Center on Link 16. The Global Hawk is still on station at 0800. It will fly another 6 hours before returning to Al Dhafra Air Base. The imagery it collected from that single orbit will generate 4 separate intelligence assessments before the airframe touches down. The destroyed Tor battery is already being photographed by a commercial satellite passing overhead. Crater coordinates push to a strike cell that is now building an assessment of what Iran chooses to replace first and how quickly the logistics chain can support it. 3 Iranian missile launches, 0 intercepts, 1 battery destroyed, 1 fast attack boat mission killed, and the drone they were shooting at never once stopped watching them do it.